consider the vector space V equals to R4 to R4 over R4, and two subspaces of V defined as W1 and W2. These are subspaces of vector space V. We have to find dimension of W1 W2 intersection and sum of W1 and W2. To solve this problem, we have one formula regarding dimension. Dimension of sum of subspaces can be written as dimension of W1 plus the dimension of W2 minus dimension of intersection of W1 and W2. This is the formula we will use to find dimension of one of subspace if others are given. As W1, we can say this is a null space, as W1 is a null space and W2 is also null space. Because of in this normally we will not call null space because of it look like as null space x y z w. This element belongs to W1 if 2x minus y plus z equals to 0, and the second condition is x plus y plus w equals to 0. If we will form matrix representation of this subspace or equation, what we have 2 minus 1 1, 2 minus 1 1 0, and 1 1 0 1. So we have two rank of this matrix as 2, so nullity equals to 2. Nullity is also 2. Rank tell us the number of linearly independent columns or rows. From this we can say there are two linearly independent rows. So we have, because of there are 4 constituents in element, so 4 minus 2 equals to 2 will be the dimension of W1. Otherwise you can tell number of free variable means by nullity. So dimension of W1 is 2, and try to find dimension of W2. Procedure is same. Write matrix representation of equation from W2. Matrix equation will be 1 minus 2 1 minus 1 1 1 0 0. So there are two pivot element, this and this, so we have rank 2 and nullity 2. So dimension of W2 is again 2, but in option given 3, that's why this is wrong. To find dimension of intersection, we have to consider an element which satisfying the condition of W1 and W2 together, and that element will be that element. So first suppose this element normally x y z w, this is considered in intersection of W1 and W2. It means this one satisfy the condition of W1 and W2 as well as W2. 2x minus y plus z equals to 0. This is the first condition of W1. X plus y plus w equals to 0. X minus 2y plus z minus w equals to 0, and x plus y equals to 0. So these are 4 conditions from W1 and W2. Write in matrix representation. So 2 minus 1 1 0 1 1 0 1 1 minus 2 1 minus 1 1 1 0 0. This is the matrix representation of equations from intersection. Now apply elementary row operation and try to find out how many rows are independent or columns. Means if you find the rank, then you are done, or nullity, then again you are done. Apply elementary row operation on this. We have 2 minus 1, there is no change in first row. 0, or you can interchange R1 as R1 to R4. So 1 1 0 0 to, again 1 1 0 0, 1 minus 2 1 minus 1, and we have 2 minus 1 1 0. After applying elementary row operation, what we have? Dimension of intersection. Dimension of intersection means dimension of intersection is 1. You can find apply elementary row operation and easily you can find dimension of intersection. Now use formula as told in earlier of this section. So dimension of sum will be dimension of W12 plus dimension of W12 plus W2 minus 1. So dimension of sum will be 3. So this option D is also correct. Option C is also correct. So key for this problem is A, C and D.